A warm welcome to one and all present here. I, Shivani Prasad, am a representative from ISTE-VIT and I will be your host for today's webinar, Unlocking Java Collections. Indian Society for Technical Education, ISE, is the leading national professional non-profit society for technical education with the motto of career, personality, and holistic development of the students. Our objective is to create and assist top quality professional engineers whose skills and capabilities are sought after by larger industries and organizations. We organize technical workshops, hackathons, and codeathons to find and enhance the hidden skills in the students. Horizon is an annual national technical summit hosted by ISTE-VIT. The summit includes a massive hackathon, Technica, and a slew of other events and workshops in a variety of fields such as web development, machine learning, pure electronics, IoT, Web3, app development, and competitive coding. It is one of the largest technical fests which observe over 1,500 participants and is designed to achieve technical excellence. Technica is a 48-hour hackathon held in Horizon by ISTE-VIT with a goal of inspiring participants to push their limits in the quest for excellence, with around 1,000 participants and an array of creative ideas for a more technologically promising future. It is a multi domain hackathon with the goal of providing innovative technical solutions to real world problems in areas such as education, fintech, artificial intelligence, hardware, and open innovation. Today, we have Rachit Jajoo, the technical head of ISTE, with us. I'm honored to introduce him as he has been a pivotal member of our team for our technical success. He will be taking over the webinar from here. Rachit, the stage is all yours now.
Thank you so much. Uh, Hi everyone. Today we'll be learning about Java JCF, that is Java Collection Frameworks. So the first question arises to us that why do we need these Java Collection Frameworks? So we can see that Java Collection Framework is a set of classes and interfaces that Java provides us for an efficient way to collect, store, and do our tasks. The collection framework is an architecture for representing and manipulating collections of objects and including a wide range of data structures such as lists, sets, and maps. We also have queues, stacks, and other types of data structures that we would be studying today, and we will see how we use them in our day-to-day problems. So we can see that there are many types of interfaces in the Java collection framework. These interfaces are lists, queues, sets, and maps. We'll be starting with lists. But first, what are interfaces? So before interfaces, we need to understand what are classes. So when we create an object of a class, we define the different methods and functions that an object can do. Suppose we have a car. So for a car, we'll define its speed, the power, the horsepower it has, and the type of engine it uses. So that is how a class is defined. Now, an interface. So, what's an interface? An interface is what a class must include. So, like class, an interface can have methods and variables, but these interfaces do not classify what these methods would do. They just specify what a class must contain and not how the function is used. So now we will be starting with our list interface. So for list interface, we will be using ArrayList. So why do we use ArrayList? Basically, when we use arrays, we all know the use of arrays. Suppose we have an array named ARR and it is of integer type. We declare it using new integer and we give it a specific value, the size of the array, suppose as 10. Now, if we add 10 elements to the array, the array would work perfectly fine. But if you want to add another element to the array, it is an problematic situation because we have predefined the length of the array, and now we cannot increase the size of the array. So basically, an array is uses a static and whereas an array list uses a dynamic one second dynamic type of memory allocation. So when we start an array list, we can add as many elements as we need. So if we do not have to specify the number of So we do not have to specify the number of elements that the array list must contain. So we can keep on adding the different units of elements in the array list. Okay, so now we would be so the next thing we would do is we will see how to declare an array list. So to declare an array list, we basically write list. Then we specify the type of the object we need, suppose integer or character or a string. And then we give it the name of a variable, suppose list, or I'll give the name as L. And then we allocate it using array list. Now, what are the different functions an array list can have? So we have 3 to 4 functions in an array list. First, we can add the elements in an array list. So for to add an element, we do l dot add the name of the list, and then we do dot add and we add the element. Suppose 10. So we can add like 15 also. We can add 20 also. So we can add multiple elements in the array list. The second function we have is we can get the index, get the value at a particular index. So suppose we I want to print the value of the element at the index 1. So I do l dot get the value at index 1. And if I run it round, I'll get the value 15 because the current list contains 10, 15, and 20. So we can also do l dot get value at 2. So giving a value at 2 will get 15 and 20 because at index 1 we have 15 and at index 2 we have the value 20. Now we can remove elements from the array list also. We have to do remove and we have to specify the value of that object. So suppose I write l dot remove 15. So what this does is it removes the value 15 from the array list. And now if we print the array list directly, we will have only the elements 10 and 20 in it. Oh, okay. So here we have to give the index and not the object value. So suppose I give the index value as 1, we will have the array list as 10 and 20 only. So here we can see that the initially the array list was 10, 15 and 20, but now after we remove the element at index 1, that is 15, we get the array list as 10, 20. So these were the different functions of an array list. There are many types of questions that we can use using array list. Let's take an example. So suppose we have been given a list of numbers. Suppose we take this list as number list and of type integer, naming it as L, and we define it as new array list. Now we add some integers. Suppose 1 to 10. Suppose 1, 2, 3, 4, 5, 6. Okay, suppose we have added from numbers 1 to 6. Now, what do we want to do is we want to get the sum of all the values. So what do? We initialize a variable called sum with 0 and using a for each loop. So there's a for loop and a for each loop. What a for each loop does is okay, so people have some problem with for each loop, so we will be using direct for loop. So suppose I will take a integer from I equals to 0 to iterate over all the elements of the array list. I will have I is less than the length of the list, array list dot size, and I'll increment I. So what I will do is I will just add all the elements of the array list to this sum. So to get the value at index I will use the function l.getI, and at the end I will print the value of sum. So this way we get the total sum of all the elements in the array list. So we can see that 1 plus 2 plus 3 plus 4 plus 5 plus 6 will always give us 26. If we want to get the product of all the numbers, we can do it in the same way. Suppose we initialize the product with 1, and instead of adding the numbers, we multiply the numbers. Suppose we do product into is equals to array list, the list dot get at index I, and then we will print this value add of product. So we will get the value of 6 factorial, because why? We are doing 6 into 5 into 4 into 3 into 2 into 1. That gives us basically 6 factorial. And we know 6, the value of 6 factorial is 720. So if we run this value, we'll get the value 720. So that's how ArrayList works. And we have few more functions of ArrayList to get the size. Suppose we want to know the size of the ArrayList, we initialize the variable size and we do l.size. So this size, the value of this size would be 6, because there are the number of elements are 6 here, 1, 2, 3, 4, 5, and 6. So if we print the value of size right now, we will get the value 6 with us. Yes, so we got the value of the product, and this is the value of the size of the array list. Next, we would be starting. Next, we'll be starting with stacks. So, what are stacks? A stack is a data structure that uses the concept of last in, first out. So, what it does is it stores multiple elements in it, and the last element that we input will be the first element that comes out of the stack. So, how does this work? I'll show you right now. Suppose I add a few elements, suppose 10, 20, 30, 40, 50. So I add them in this order. First 10, then 20, then 30, then 40, then 50. So when I when I want the first element out of the stack, it will give me 50, because 50 was the last element that was inserted in the stack. So now I will show you. So this is what is called a last in, first out structure. Last in, first out structure. So I'll show you how to initialize a stack. To initialize a stack, we just write stack. The data type the stack should contain, suppose integer, and then the name of the stack, suppose S, and then we initialize with we initialize the memory using the method new stack. So this way, a new stack is created. Also, to initialize the stack, we need to import some packages. So to import the packages from the Java collection framework, we directly import java.util.all. For all, we just write star. Star means it accesses all the packages inside the java.util framework. So now, suppose I add. So to add, we have a function called push. So what the push does is the push inserts an element into the stack. Suppose the first example that we gave, inserting the values 10, 20, 30, 40, and 50 into the stack. So we'll be doing that right now. So I'll push the elements 10, 20, 30, 40, and 50. So these are the elements that we are going to push into the stack. So now the stack creates a structure where 50 is at the top. Then at the next line we have 40. In the next line we have 30. In the next line we have 20. In the next line we have 10. So when we first pop, so what is pop? So pop means we just remove the top element from the stack and give it to the user. So suppose we want to print the top element. So what we do is we directly write s.pop. So what this does is this will give us the value 50 directly. So let's see when we run this. So we get 50 as the first value. So after popping, what pop does is pop removes this element from the stack and gives it to as an integer. But if we don't want to remove the top value and just want to see what the top value is, we use a function called s.peak. So while using pop, we have removed the 50. So we remove this right now. But now when we use s.peak, we have 40 right now. We don't remove this 40. We just see that what is at the top of the stack. So now if I print, I will get 50 and then 40. So if I save it and I run it, you will see that I get 50 and 40. But now, if again I do s.pop, so now what I do is I'm removing this 40th value and this value is coming over here. So this will be removed over here and the output that we should get is 50, 40 and 40. So let's see if we get this. Yeah, so see, we got 50, 40 and 40. Why are these two 40 coming? I hope this is clear to you all. I'm in the. If you guys have any doubts, you can comment in the chat section. I'll be addressing the doubt to you right now. About stacks and lists. If you guys have any doubts, please write it in the comment section. I will be checking it right now. So this is how stack works. Now we will be taking a question on stacks after your doubts. Okay, so I see that you guys do not have any doubts right now. So, okay, we will skip to the next question. So, the question states that we have to reverse a string using stacks. So, how does this work? Suppose we have been given a string. Suppose the string is my name is Rachit. So now I have to reverse the whole string and I would get the value as the output should be TICHCAR and so on, like SIEMAN and YM, right? So this is what the output should be. So how do we do it? So first we take the input, the string as an input. Suppose the name of the string is str. We take this as an input. So the input would be my name is Rachit. So now what do? we have to use a stack to reverse the whole thing. So we know that stack uses a last in, first out structure. So what do we do is we iterate over the whole string, and for every element we encounter, we add it to the stack. We just push the value at the ith index to the stack, and then we start popping it out. So first, suppose m goes, then y goes, then n will go, then a will go, and so on. The stack will go. Okay, so I'll show you right now how it goes. So create a stack. Now the stack should contain the type character and not a integer value, because I need to store these characters, suppose m, small y, and n, and a. So I am going to create the stack of type character, and I'll give the name of the stack as s, and I'll initialize it with new stack. Now what do? I iterate over the whole string. How to iterate over the whole string? I take an iterator, I suppose. I will start from 0, and it will go till the length of the string, and I'll increment I. Now what do is I add the value at index I of the string to the stack. So what I do is I find the character at index I declare a character ch at suppose index I. How to do that? Str.char at index I. So this will give you the value, the character at the index ith index. When suppose I is equals to 0, my ch would be m. When I is equals to 1, my ch would be y, and so on. So now I've accessed the character at the ith position. Now what do? I just push them onto the stack. So directly I push them onto the stack. Now if I want to see what the stack, the value at the stack, but see, if you want to access the values at the stack, if you think that we will write system.out.println and s, it would give some error. Why? Yeah, so we have spaces over right here. So we want to remove the spaces right now and only have this total value with us. So we remove the spaces from the string originally, and we now run the program again. Okay, so here I get my name is Rachit. So this is the current value of the stack. So what do I do now? I create another string that will be the final answer, and I initialize the string as an empty string. Now what do? I pop the values from the stack till the stack is empty. So how to do that? I'll take a while loop. Now what does the while loop do? The while loop will run until the stack is empty. So suppose I pop this value T-I-C-H-A-R until I reach M. And after I pop M, we know that the stack would be empty. And then the while loop would stop. So to write this, I will do when still the stack is not empty. So to do that, I write s dot is empty. So what does this do? We have a not operator right here. So when the stack is empty, this would become false, and this loop will terminate. So what do is I add the final answer, and I add the value at final answer will be equals to final answer plus the value at s dot pop. So how does this work? This works as in the first iteration, my final answer would contain T. Then in the next iteration, we'll add I, then H, then C, then A, then R, and so on. And that's how we get the value of the final string. So now if we print out the final string, we can see that the answer would be in the reverse order. This is the reverse. Okay, so if I also print the value of str and remove the stack value, so you can see that I can do it. The original original string was, and then I can add the value of strs. And here, instead of directly doing this, we can add the reversed string is so. Here you guys can see how we are getting the reverse string. So here my name is Rachit has been reversed using a stack. So do you guys have any doubts till now? Please do ask in the comment section. Do you guys have any questions till now, or is it fine for you all? Okay, Shashi, you don't have any doubts. That's nice. Suryansh, no doubts. Okay, guys. If this is fine, then I'll move on to the next topic. That is queues. So now that we have learned stacks, we will be moving to queues. Now, as we saw earlier, that queue is an interface. So here you can see that the queue is in the blue box, and blue box are interfaces. Now we cannot directly make objects of interfaces. So what do? We implement queue using linked list. Okay. So here we come back to queues. So first we will be using queues using linked list, and now let us understand what a queue is. Like stacks, we had last in first out structure, but in queues we will have first in first out structure. So what does this happen? Suppose you are in a queue to get a ticket for a movie. So what do? You get in a line, and the first person who gets in the line gets to the ticket counter first and gets the ticket at the first. So that's how a queue works. So in the queue, the first object that is inserted is the first object that is removed from the queue. But whereas in a stack, what happens? The last object that is inserted in the stack is the first one to come out. But in the queue, the queue uses a first in first out structure. I hope that's clear to you all. So I will remove all this, or I will comment this out, and I'll show you uh, how a queue works. So this structure that a queue uses is called FIFO, or first in first out structure. So how does the first in first out structure use implements? Suppose we have five elements again. Suppose 10, 20, 30, 40, and 50. So if we have these number of elements in a queue, so after adding these elements in the same sequence, we remove the first element, and the first element that would be removed would be 10 and not 50. Like in the stack, the first element that was removed was 50, but in this the first element that would be removed would be 10 because of the first in first out structure. So now we will initialize a queue. So a queue is initialized using the keyword queue. Then the class it uses, suppose an integer. So we will make a queue of integer type. Sorry, yeah. So integer type, and we will give the name of the queue as queue. And this would the queue is implemented using a linked list. So we saw that because the queue is an interface, we cannot directly write queue is equals to new queue like this. This is not accepted because queue is an interface and not a class. So we use queues using linked lists. Now, suppose we start adding. Suppose we add numbers from 1 to 6. So I'll take an while loop, for loop. Suppose from integer 1 till integer 6, we will add values in the queue. So queue dot add, and the value would be I. So here, when we print the queue, we will see that the values in the queue are 1, 2, 3, 4, 5, and 6. Yes, so 1, 2, 3, 4, 5, and 6. So here, the first value that was added was 1, then 2, then 3, then 4, then 5, and then 6. So if like if previously, we have few functions of queues also. What are these functions? These functions are add, remove, and peek. Remove and peek. So how to add? We saw we just write q dot add and the value of the element. So if I just write here q dot add and value would be 100, then and after this if I print the q, if I print the q right over here, then the value would be updated from 1 2 3 4 5 6 to 1 2 3 4 5 6 and then 100. So if I run it right now, you can see that the first value of the q was 1 2 3 4 5 6, and now we have 1 2 3 4 5 6, and then we have a value of 100 that we added over here. So now what do? We have done the value of addition in a q. Now how to remove or peek the value of a q? So how to peek? So let's see over here. So the what peak does is peak will see what the top of the queue is or what the current element that would be that should be popped if we use the remove value is at the queue. So suppose I do q dot peak, this would give me an integer. Okay, so I will just access this using integer a. Suppose integer a, I do q dot peak. Now I can directly print this value of a. So what should be the value of this q? This value of a. Anyone has any idea? If you can, if you guys have any idea, you can type in the comment section. I will be watching that. Guys, do you guys have any idea of what the value would be? If you have, please write down in the comment section. Okay. So the value at A would be 1 because the first value that we added was 1. As we remember, if we print the Q, we got 1 as the first index. So the values were 1 2 3 4 5 6, and then there was 100. So the first value that would be peaked will be a 1. So if we run this right now, we will get the value of 1. So after this, we can do the value, we can do with the function of remove. What the remove does is, we remove the first element and just like p, we will get the value of the first element. But here, we would remove this first element entirely from the queue. So if we directly do q dot remove, what it does is, it removes the value 1 from the queue. So now if I print the value at the if so it will also be 1. So here we get two ones right over here. So okay, we don't need this. So now we would be taking a question. What we would be doing is we would be implementing a stack using two queues. So how do we do this? So to do this, we create a suppose we create a class called SP. We first create a class that and we name it STCK because we already have stacks in our Java collection framework. We use the keyword STCK. So we create a static class called STCK. Now, what do we have here? We would have two queues because we want to implement a stack using two queues. What do? We create two queues in the stack. So we create two static queues of type integer, suppose. We name it Q1, and this will be implemented by linked list. Similarly, we initialize another queue called Q2, that would also be initialized using a linked list. So here we would be having just one function right now. That would be the value of push. So how do we push the value in a stack? So we know that if a stack is there and we have the value 10 above the stack, and if we push a value, suppose we want to push the value of 20. So what do? We push the value of 20 above the value of 10. But whereas in a queue, what happens is when we push the value 10 and 20, the 20 would come after the value 10. So what do? If there is a value of 10 in the stack q1, suppose q1 is equals to 10, and now I want to add the value 20. Suppose then what do? Is I add the value of 20 to q1, and then what do? I completely just what I do is I take another queue, the second queue, that is q2, and I transfer all the elements from q1 to q2. So how does that work? So the values of q1 that I will remove would be 10 first here, and then 20 over here. Then what do? Okay, suppose I have to add 30, not 20. It would be easier for you guys to understand. So here, 20, I have to add the value 30. Okay, so I'll keep it over here. So the q1 value were 10 and 20, and q2 was empty before. Now what have we done? We have shifted all the elements of q1 to q2. Now the value of q1 is empty. And then what do? We add the value of 30 to the q1. And now we now copy the values of q2 back to the values in the q1. So what happens is here, we remove these two elements and we just add them over here. So now we can see that the queue implements a kind of a stack. Therefore, when we added 30, the first element that came was 30, then the second element that came was 20, and then the third element that came was 10. So this is how we create a stack using two queues. So I would remove all of this. So now what do? We will take an integer, suppose integer number, num. So what do? I will first add the value q in q2. So I do q2 dot add the value that is given to us, that is num. Then what do? Until and unless q1 is okay. So we do not add it right away. Sorry, that was my bad. What do? Is first we take while q1. So the main queue that we are using is q1. So while q1 is not empty, what do? We keep on transferring the values from q1 to q2. So how do we do that? q2 dot add values at q1. Okay. So this is how we transfer all the elements from q1 to q2. Now what do? We add the num element to q1. So q1 dot add, and then we will have the value of num. Here we added the value of num. Now what do? We transfer back all the elements from here back to the value of q2. So we do while q2 is not empty, is empty. We give q1 dot add all the values from q2. So that's how we implement the push function of a stack using two queues. Similarly, we can we can create functions of remove, we can create functions of peek, and we can create functions of printing. Okay, so I will add another function that will help us print the value of the whole stack. So here we have a stack. So how do we while q2 q1 okay, so while not q1 is empty, we keep on printing the values in the q1. So what do? q1 dot pop, q1 dot remove, sorry, we have function of pop in stacks, not in this queues. So we'll add just a space over here, And now what do? We create an object for the given stack. So stack S will be a new stack. Okay. So now what do? We add functions. We had the function of push. So what do? Is we use the push function s dot push, and we give it values 1, then s dot push value 2, then we do s dot push value 3. Now, if you want to see the values, we can directly print the values in S. So how does this work? We'll see now. So we saw that the last element that we inserted was the last function that we inserted was 3, then 2, then 1. In the similar way, the stack implements. First, we got 1 that was inserted at the first, then the second, and this third was inserted at the last. So that's how we implement a stack using two queues. So this is a vital question in interview rounds, and also in competitive coding, we might get such questions where we need to implement such ideas. So this kind of structure would be helpful to you all. I hope you guys saw and understood how this works. So after this, we have done with our queues and what are the different functions in a queue. So now we will be jumping to priority queue. So what is a priority queue? So we know we have seen what a queue is. Now what we will do is we will learn about priority queue. So we will remove all of this here. So seeing the word priority, what does it sound? It sounds that we give priority to someone. Suppose you are in a VIP line and you are in a ticket line, and there's a VIP line also there. So what the VIP line does is, if someone important is there in with you in the line, they forward it to the front of you. So if the president of India, suppose he comes in the line, he would jump directly to the front of the line, and you will still be there where you are. You won't be allowed to go to the front directly. So what a priority queue does is it sets the priority. Okay, so how does this priority set? It sets in ascending order. Okay, so what do you mean by ascending order? If I say, so suppose I implement a priority queue. How to implement a priority queue? We just write priority queue, and then the class that it takes, suppose integer or character or a string. So I do priority queue pq is equals to new priority queue. Note that priority queue and queue have almost all these functions as same functions, and they have the same name. So suppose if I add values, suppose 100, then I add the value of 10, then I add the value of 1000. So according to a queue, what should be the order here? So if it was a queue, if it was a queue, the order should have been first 100 would have been there, then 10, then 1000. But because it is a priority queue, in priority queue, the order changes according to the ascending order. So what the order here becomes is, first the 10 comes, then it would be 100, and then 1000 would come. So this would be the original we order right now. So how do we check it? We simply print the priority queue and check if the order that we think is there or not. So yeah, you can see that instead of a queue with 100, 10, and 1000, we will get 10, 100, and 1000 as we have it right here. So what are the different functions in a priority queue? These functions are the same. So the first function is to add an element. So we add, suppose, the value 10. The second function is remove. So we have the value of remove function. We have the value to peek the elements. So here first, suppose we peek the element, then we remove the elements. So we don't get any errors because there is only one element. If we remove it, the queue will become empty. So here we remove it, and then we have another function called isEmpty. What does isEmpty do? It gives us either a true or a false value. When does it give a true value and when does it give a false value? when does it give a true values? Let's see now. So if the priority queue is empty, suppose I have removed all the elements from the priority queue. Now I will print that if the priority queue is empty or not. So what does it give us right over here? It gives us true. It should give us the value true. Okay. Okay. There was a mistake. Okay. Yes. So right over here, we would get a value of true and not false because we can see that we had one element in the priority queue and we have removed that element right away. So the value would be that would come would be true. So we get a value of true. But now suppose we add two elements. So priority queue dot add 20. So here we would get the value as false. So we will run this again. And as you can see, the value that we got is false because the priority queue is not empty. Okay. So these were some functions of priority queue. Now there's another function called poll. Now what does poll mean? So this function poll is present in stacks, queues, and priority queues also. Okay, priority queues also. Now what does poll do? Okay, suppose we have a stack. Okay, so we have a stack of integer type s, and we initialize it with suppose new stack. So what happens if I directly do s dot remove? Since there are no elements, okay, not remove, pop. Since stack has functions called pop and peek and push, if we do pop, what does this do? This will give us an error. Why would this give us an error? Because there is no element present in the queue right now. So if we run it right now, you can see that we get an exception that there is an empty stack. But what if we write s dot poll? S dot poll, what does it give? Okay, okay. So what does this do? Okay, I'm extremely sorry. Stacks do not contain this method. It is present in queues and priority queues. Okay, so I will take a queue, integer queue that is implemented by linked list. Now what do I do is if I do queue dot remove, this would give us an error that the queue is empty previously only. So what do? Is we clear this. So we can this no such element exception. Why there is no such element exception? Because there is no element present in the queue. But what if we do poll? What is poll? Poll will give the value of null. If there is no element present in the queue, this poll function gives us a value of null. So what is null? Null is like no element exists, or there is no data type present in the stack in the queue right now. So here you can see that if we do q.poll, okay, so we'll print it right now. There's no output because we have not printed it. So here if we print the value q.poll, what happens is we get the value of null. So that's the difference between remove and poll value, POLL. So that's how we do it. So the next topic that would be that we would be taking. One second, I will remove all of this for you guys. Yes. So we have seen what is the priority queue. Now we will be jumping to the next data structure that is called a set. So what is a set? Okay. So if we have seen that there are many elements. One second. Okay. Yeah. So we see that sets. What is a set? Set is what this set does is set is data. It does not allow existence of duplicate elements. So suppose there are 10 elements numbered from 1 to 10. So not number from 1 to 10. There are 10 elements and there are two ones and two twos in that. But what a set does is it does not allow duplicate elements to come. So one would always be added only once in the set. I will show you right here. So how do we declare a queue? Declare a set. So it's the same as a previous one. We write set. We write integer, the data type it takes. and then we will give it the name as S. Suppose S, we give the name as S, and since we know that set is also an interface, set is an interface, so we initialize set using hasset. What are hasset? Hasset is a class that okay, hasset is something unique. Hasset is the class that implements hashing. Okay, so what is hashing? We will be learning in a few moments. This hasset uses the hashing function to create these sets. So, so what do? So suppose we add to a few elements, suppose one, and we again add elements one, and then we add element two, and then we again add element two, and then we add some elements like 45. Suppose s dot add 12, 10, then s dot add 12. Now, if we print the total set S, what we will get is we only have the value of one only once, and also we will have value of two only once, because sets do not allow does not allow duplicate elements to exist. Okay, so how does this occur? So you can see that we have 1, 2, 10, 12, and 45. But you can see that I added 45 before 10 and 12, but 45 came at the end. So how does this work? So this works because this happens because sets are unordered. So what is unordered? That it does not depend that if we add one in the starting, that one would be given at the first index. It is a mere coincidence that one and two are at the first two indexes, and that the list is the set here is sorted. So what actually happens is this set that we get can be of any random order. This is because the sets are unordered in actual. Okay. So here we can see we get this value. So we added 45 before 10 and 12, but we got 10 and 12 before 45. So if we use hash set here, you will see that we will get a totally different pattern over here. Okay, so the pattern is same only right now, but it does not generally happen that way. So now what do? Is we okay. So there are some functions of sets that we will learn right now. Okay, so what is the first function? Suppose the first function is addition of any character. 10. Suppose we add the value of 10. We can also access the size of the set. They just have to do it with s dot size, and we also have s dot is empty. What is empty gives us if the set is empty or not. If set is empty or not. So if it is empty, it provides us with true value. If it is not empty, it provides us with a false value. Okay, so the next function, this size, suppose right now the size would give the output as 1 because we only have the value at element 10. Okay, so now what we do is we see, okay, so set have one more type of function called contains. What this contains does is it tells you whether the set contains a particular object or not. Object, so we give a parameter over here that is an object. Suppose we give over here 10 or 0. So I'll give you the example. So suppose s dot contains the value 0 for once, and we will print this out. Okay, so we'll print this out, value of set, and then we'll also print if set dot contains value of 10. So here, if we run the following program, we see that the above function gives false because the set does not have any value 0. But here we have a value called 10. Here we have added 10. So here we have added 10. So if we print s dot contains 10, we get a value of true. Okay. So now we will learn how to iterate over a set. So these were some functions of the set. Now we will understand how to iterate over set. So here we use a for each loop. So here how for each loop does is we take an integer. Suppose the name of the integer we take it as I. Okay. So here we take it as I, and then what do? Is we directly print this value of I instead of doing like we did in Arraylist is like list dot get the value at index I. We do not do like this. We directly print the value at index at the value of I. So here, if we directly print the value of I and suppose we add some more value, suppose 13 we add 13, we add 17, we add 19. So here we will get the values as you will. Yeah, so you can see that the first value that we got was 17, then 19, then 10, then 13. Why was this so? As we have already discussed about, before, that these sets are unordered data structure. So the order does not always maintain. So here we first got 17, then 19, then 10, and then 13. So this is how we iterate over a set. Okay, so we can remove this hash set. We can either create a object for set or a hash set. Both works with hash set. As we know, set is an interface and hash set is a class. So if we run this again, you will see that there is no such, there would be no difference. It would be the same. Okay. So now what do we do is, so we see that sets are unordered data structure. Okay. So that was written over here. Now we will take up a question. This was a question says, find the number of unique characters or distinct characters in a given string. Okay. So we will take this question right now and we will solve it. So, okay, instead of commenting out, we will remove all of these. So what do? So we take a string, suppose str, we give the name as str, and this string will contain like different characters A, B, C, D, D, E, F, G, G, H, I, J. So suppose we have values from A to J. So how many values will there be? How many distinct characters will there be? So there will be A, B, A would be 1, B would be 2, E3, D4, E5, F6, G7, H8, I9, and J10. So the output should be 10. So how do we do it? So we take a set and we take this set of type character. Why? Because we have to store the characters in the given string. So we take this as character. We give the name of this set as S, and we will initialize the set with new hash set. Okay. So So now what do? Is we iterate over the whole string like we did during the last question. So what do? Is I take an iterator int I is equals to 0. I will go from 0 to the length of the string and will increment I. So I goes from A till J. So I'll take the current character and name it CH. So here it would be named as CH. This would be str.char at index I. So what do? Now is we create a count variable that will count the number of distinct characters in the given string. How does this work? Okay. So now what we do, if we take a if, now if s dot add and then this character ch. So okay. So also when we add this, when we add a character, we get a value of true or a value of false. When do we get a value of true or a value of false? We'll see now. So if there already exists a value, suppose ch already exists in the set s, and we again add the value of ch in the set, then that time it gives us as a false. And if we are adding that distinct element for the first time, then it gives us a true. So when we add the value, so suppose we add a, we will get this as true, and this loop, this if statement would be true. So after that would be incrementing the value of count. So after this, suppose we come at a. So first we came at a, this count will increase from 0 to 1. After this, we again see the value of a. Now, because a was already added in the set before, we see that when we add this a again to the set, this would give as false. So we will not end this if statement, and count would not be incremented. Similarly, when we encounter b, we would enter this loop and count will be incremented to 2. Similarly for c, and once for d it would be true. For the second time it would be false because we had already added a value d before this. So this way we iterate over the whole string, and we see count the we take a variable count, and this count will give us the value of the number of distinct elements. So if I uh, print the value of count right now, we will see that we get the value as 10. So here we get the value as 10 because there were 10 distinct elements in the string. Okay. So now we use sets in different types of problems. There are hash set, and sets are used in multiple questions. So now we will see that how. Okay, so we all know about the time complexities of adding and peaking elements in stacks and queues. If we want to peak any element in the middle, we get the time complexity as big of n always. But in sets and in hash sets and sets, the value changes. In sets, the time complexity changes from big O of n to a constant time complexity, that is big O of 1. How does this happen? This happens because sets and hash sets are implemented using hash maps. We will be understanding hash maps after this topic directly. So now what does hash map do? Hash maps use something called hashing. So now what is hashing? Suppose hashing is something, suppose we have a data 1, 1, 2, 3. What happens is we take this data, we pass this through a hash code, and we convert this form to from 1 to 3 to something, suppose q, x, z, something like that. So this form is converted using a hash code. And now this hash code contains a key within itself, and this code is known to the code of the compiler. So this hash code is with the compiler itself. So when we access any element in the hash set, it does not have to iterate over all the elements. It knows where the value of 1 to 3 is stored using this hash code, and it directly returns us the value of this, if this exists or not. Okay. So in sets and maps, the values of adding in sets and also in maps, the values of adding, peaking, and removing from any index of any variable, it changes from big O of n to big O of 1. That is the constant time complexity. Okay. So is it clear for all of you till now? Do you guys have any doubts? You can ask. So guys, if you guys have any doubts, you can ask right now. I'm seeing the comment section. Okay, so I assume that you guys have no doubts till now, or if anyone has, please type in the comment section right now. I would be cleaning them. Okay. So I guess you guys have no doubts. I would be jumping to the next topic. That would be maps. So we saw that here maps. So we will be learning what are maps. Okay. So map is basically a data structure that stores a key value pair. So how does this occur? We have values of keys and we have this key and value. So this value is associated with a particular key. And every time this for every map, this key value should be unique. Key is always unique. So if so now this is the basic idea of a map that it contains key value pairs and there the keys are unique. So now I will show you how to initialize a map. We write map. We write two data types. The first will be the key data type, and the second would be the value data type. So suppose I keep here a string data type, and the second would be integer data type. Okay. So here integer data type. Here we will give the name as empty as map, and we will initialize this as new hash map. Okay. So now what do we do is we add values to, okay. So this is how we initialize the value of, we initialize maps. So we first write maps, we first write map, data type of key, then data type of value, then we give the variable name, and then we write new hash map. Okay. So now what do? We will see how to add values in the map. So to add values, what do we do is right. We put like before we had add and push and all other. We now in maps we have the value of put. So what do? We just write map dot put. Suppose the key value. So we have key as in the string. So suppose we write India as a key and the value suppose we write 10,000. Okay. So, okay, it is not a string, it should be an integer. So we write 10,000. Similarly, the next thing we put again, suppose Bangladesh. Bangladesh and the value would be 1,000, suppose. Okay. So now what happens is these key values should be unique. So if I directly print the value of map over here, what happens is I get the values of India and 10,000 and then Bangladesh and 1,000. So I will turn the value. So here we get this Bangladesh equals to 1,000. But what is this equals to sign? This equals to sign denotes that Bangladesh is the key and the corresponding value to Bangladesh is 1,000. And similarly for India, we have 10,000. Okay. So now we see again that we first inserted India before and then we inserted Bangladesh. But in the output, we first saw Bangladesh and then India. So why is this? This is also because maps are also unordered sets, unordered data type. Okay, so maps are also unordered data types. So what happens if I now add another key value pair with the key value same as the first value. So suppose I do like this, I give the first name as India again, and now I do it as 5,000. So what happens is this this thing overrides the first value. So what happens now? The value that corresponds to the key India will be changed from 10,000 to 5,000. Okay. So here, if I directly run it, so you okay? I have not okay. I have to print the map again. Okay. So I did not print the map over here, and now we save the function, clear the terminal, and we run this function again. So you can see that first we had Bangladesh that was associated with the value 1000, and India was associated with the value 10,000. But now, after we have done this, this line does is this updates the value that corresponds to the key India. Okay, so this line updates the value that corresponds to the key India. So here the value 5,000 can be seen over here. So now, how there are many functions of a map. So suppose we have these two over here. Okay, so we'll have okay. So we have key set. So we have key set. We have value set. So what is key set and what is value set? So what is key set? So if in a map there are many key values, right? So there is India, Bangladesh. Suppose there are 10 more countries, and I want to access only these key values and not the corresponding values that are connected to these keys. So what I do is I write a set. Okay, I initialize a set, and this set would be of type string. Okay, so this string would be of okay, so it won't be a okay. This would be suppose set. I give it a set. This would be map dot key set. Okay. So how do we do? Why are we taking here as a set? Because we know that key values are unique. We take a set and suppose we give it name as S, not taking it set because it will be confusing. We take the variable name of set as S and we give this map as key set. So if I directly print S now, I would get the values of India and Bangladesh directly, and I won't get the values of 10,000 and 1,000 over here. So if we run this right now, so you can see that the set contains the values of Bangladesh and India. So that's how we can access the key set over here. The next thing is how to access the value set. Okay, so here map dot values gives us the value set. Now we have to store this somewhere. So to store it somewhere, instead of set, we use the list. Why do we use list over here? Because values can be the values can be same. Like for India, also it can be 10,000, and for USA, suppose I get USA also. I get here USA, and I can add 10,000 over there also. But this won't give any error to us because the key should be unique, but values need not be unique. So now to add the values of to get the value set, what we do is we take a list, we give the type integer to it, we give this a name L suppose, and then we give map dot values. So what this does is, okay, there's a problem I guess. Why is there some problem? Okay, so collections dot integer. Okay, so we will use array list I guess. We'll use collections dot integer. List is equals to map dot values. Okay, there's some error coming. Okay, so why is this the error coming? Let's see. Collections of integer, we get values. So yes, we have to give some collection over here. So instead of that, what we do is we directly iterate. Okay, yeah. So to iterate over all the value pairs, what we do is we take a for loop. So for each loop, we take a for each loop, and then we take an suppose type integer, and we give this value as map dot values. Okay, we take this. We have to give suppose I over here, and this will give map.values. Okay. So now if I print the values over here, suppose, okay, so I print I, as we have seen, this is a for each loop. So we directly print I. So here we clear this out and we can see that print ln, we get this is print ln, and then we run it, we see that for USA we get 10,000, for Bangladesh we have 1,000, and for India we again have 10,000. So that's the order that is maintained. It is unordered, but still the order of the key and value pair is always matched. You can see that USA has 10,000, and then Bangladesh has 1,000, and then India again has 10,000. Okay. So now what do? We again take up a question. So what the question is? Okay. So what are we given is give the count of all the unique characters in a string. So what do we have to do in this question right now? Let's see. So suppose we have a string. Suppose let's take up a string with someone's name. Okay. So Kartike. Okay. So we are going to take. Okay. Where's the name? Okay. Car ticket. Okay. So here we will take this as a string and then we have to return the number of times K has occurred, A has occurred, R has occurred, and A, R, T, and E has occurred. So what would be the output? K has occurred twice, A has occurred only once, then R has occurred only once, T has occurred once, and E has occurred twice. So this would be our required output. So how do we do this? So first we take a string str, suppose we take the name of k over here. Okay, so we take the name that's k over here. Now we define a map. So map would be of character. So we know why we are taking character and integer. Why are we taking integer? Integer is there because we integer maps the value, the number of times a character has occurred in the string. So we give this name as map and we implement the map using new hash map. Okay. So now let's see how do we do. So for we again take an iterator I is equals to 0 and this goes till str.length and we increment I. We take the current character as ch. So current character will be str dot char at value I. Okay. So first the value would be k here. Then when I is equals to 1, we will get a, then r, and so on. Okay. So okay. So we take it as this. Now we check if this map contains this key. So what does this contain key means? Okay. So I'll show you right now. Okay. So if already my k is mapped to some value, suppose 1 or 2, then this value will give true because k is already present in the map. So what I do is I get the value of int. Suppose I take the value of int, like the number of times k has already occurred is 1, suppose. So what I do is I take the value and what I do is I get map.get. What does this get function do? Okay, so in this get, I just pass the value k. Suppose I pass this value k, and this will return me one. If k is mapped with value one, this function map.get k would return the value one to me. If k was associated with value two as its value and key pair, this would have given me value two. So what this does is now I got the number of times k has already occurred in my map or my string. So now what I do is I increment the value of the value. Why? Because we have encountered k again and already it was one. Suppose this was one, and now I have encountered k again over here. So what I do is I get one and I increment value to two. So now I would put, like we had seen, I would put again ch comma val. So what this does is this will now associate k with 1 to k with 2. Okay. So we know that using put function again, we update the value of k with 1 to update the value with k with 2. So this goes on until we have reached the end of the string. Now we will take another case. What if we have not seen the element till now? So suppose we first encounter a. So we first encounter a, and a is associated with nothing. So it would be null because it was associated with nothing, and we know nothing refers to as null here. So what do? Is we directly put map dot put the value of ch and a value of 1. Why 1? Because a is coming, suppose we come to a, so a is coming here for the first time, so the value of a would be 1. So we are keeping the value 1 over here. Now what do? We iterate over. Okay, so now we can directly print the map over here. So if we clear this out, and okay, so we run this. Okay, so you guys can see. Okay, so E was supposed, okay, why is E 3 times over here? Let's see. Uh, okay, so it should not be K over here, it should be CH. Uh, okay, so this should be CH, not K. I will clear this out and then we will run it again. So yes, we can see that K comes twice, E comes twice, T comes once, R comes once, and A comes once. So this is how we use a hash map or map to find out the number of times then an particular distinct character comes in a string. So yes, that's how we use a string, how we use maps. Okay, so do you guys have any doubts for now? We will be taking up questions from the chat section. Anyone has any question? Okay, so I suppose that no one has any doubts till here. So this, so we would take up some questions, and if you guys do not have any questions, so we would be ending our meet over here. And I would like to hand over the meet to Shivani again. Are you there, Shivani?
Yes,
Okay, yeah.
yes. Okay. Thank you, Rachit. This webinar surely did turn out to be very informative, and I'm sure that the participants have learned a lot today, and they will be taking away some valuable insights. Thanks to all of you, as it was your engagement that made this webinar a successful event. I would ask the viewers to fill in the attendance form, which will be sent to the chat box shortly. You can follow us on our social media handles, the link of which is given in the description box. This is your host, Shivani Prasad, signing off now. Good night, Technical Titans.